Hello everyone. So in this video lesson, I'm going to show you some of the answering techniques for your chemistry paper 3. Okay, so chemistry paper 3 is a paper that is all about experiment. So you need to do some experiment for this particular paper. Yeah, you need to do some experiment for this particular paper, and then you need to answer the question, okay, after the experiment. Okay, after you do the experiment, then only you need to answer the paper. Yeah, okay, so what we need to know here, okay, so first of all, when you answer the paper 3, you don't need to use some very technical or some very fancy words to answer it. No, okay, a simple rule is that I want you to use a rule called KISS. So KISS is a short form for keep it short and keep it simple. Yeah, keep it short and simple, which means that when you answer the paper 3, your answer, you just need to give some very short and very general, very basic answers. That is more than enough for you to score your paper 3. Yeah, you don't need to write a super long answer like what you did for your paper 2, like what you do for your essay. No need. Yeah, so I'm going to use one paper to demonstrate, to show you step by step how to tackle, how to answer those questions. Yeah, so this question that we discuss is from MRSM trial exam paper. So this is a soalan percubaan trial exam paper from MRSM year 2022. Okay, so let's start. So first of all, when you want to do the experiment, you always need to spend 5 minutes to check all the apparatus. So you need to check whether you get the right apparatus and the right quantity or not. Use first 5 minutes for the checking purpose. So after you check, then only you carry out all the experiment using the steps given here, all the steps given here. Okay, so this experiment is about something we call it as heat of displacement. So let's read. So this experiment we want to do is all about heat of displacement. So what we need to do here is that, so we will use the zinc powder to mix with copper sulfate solution first. You see, zinc powder put in the copper sulfate solution. Yeah, we want to do the heat of displacement. Yeah, so I hope everyone remember what is the concept of displacement. You learn about the concept of displacement in your Form 5 Chapter 1. Form 5 Chapter 1 under the redox. Yeah, you learn about displacement. So can we spend about 2 to 3 minutes to do a revision? What is displacement all about? So displacement is a concept, I call it as gangster bully concept. A gangster bully concept. Okay, what is gangster bully concept? The more powerful metal will rob the girlfriend of the less powerful metal. I repeat, the more powerful metal, they are able to rob, they're able to take away the girlfriend of the less powerful metal. So example, so in this case we have a zinc and a copper sulfate. So if you look at it, this is zinc and this is copper sulfate. So how to know which metal is a more powerful gangster? How to know among the zinc and copper who is the more powerful gangster? So you have two methods to do it. First of all, you can refer to the ECS. So ECS is called electrochemical series. Electrochemical series. Okay, so hope everyone know about your ECS. So the higher the metal in the ECS, they are more powerful gangster. Okay, the higher the metal in the ECS, they are more powerful gangster. So more powerful gangster means they are more electropositive. So if they are more electropositive, they are able to rob the girlfriend of the less powerful one. So you see, this is zinc and this is copper. So as you can see, zinc is a more powerful gangster than copper. So what happened? Zinc can rob the girlfriend of copper. Who is the girlfriend of copper? Sulfate. So when zinc rob the sulfate away, you become zinc sulfate. When the sulfate is taken away by zinc, so now the copper has no girlfriend. So now the copper stand alone. So this concept called displacement. Okay, displacement. Okay, if you don't want to use ECS, there is another way you can use for displacement, which is looking at the standard electrode potential. So sometimes they might give you standard electrode potential. So standard electrode potential is what we call E0. E0, this circle called naught, E0 value. So the idea is very simple. The more negative E naught value means it is a more powerful gangster. Okay, the more negative the E naught value, it is a more powerful gangster. So for example, you see, we have zinc and copper. Zinc, the E naught value is negative 0.76. Copper is positive 0.34. So who is the more powerful gangster? Zinc. Because the value is more negative than this one. So the more negative the E naught value, the more powerful gangster it is. Okay, so you know lah, zinc is more powerful gangster than copper. So zinc can rob the girlfriend of copper, so become zinc sulfate. And after you rob the girlfriend, now the copper stand alone. Okay, so you can use ECS or you can use electrode potential value to determine who is the more powerful gangster. Okay, so that's what I want to tell you. So how we do this experiment? So first of all, we put the copper 2 sulfate solution into a polystyrene cup. So first of all, take a polystyrene cup, put in the solution. The solution is copper sulfate solution. So this copper sulfate solution, how much we put in? We put in 50 cm cube, that is the volume, and we put in 0.1 mole per dm cube, that is the concentration. Yeah. So after we put in this solution, so what is the next thing that we do? Okay, what is the next thing we do? So you see, we need to measure the initial temperature. We need to measure what is the original temperature, because the temperature reading can be seen on the thermometer. So if you look at thermometer, you know what is the initial temperature value. So we need to measure the temperature value and we need to put in the table. Yeah. So after that, we put in the zinc powder into the copper sulfate solution. Yeah, we put the powder into the solution immediately. Okay, then we use a lid. We cover up the lid with the we use the lid to cover up the polystyrene cup. Okay, so this is the polystyrene cup. We put a lid here. Okay, why? Because when we do all the experiment that involving heat, when you do any experiment that involve heat, you don't want the heat to run away. You don't want the heat lost to surrounding. You don't want the heat to run away to surrounding. So when you put a lid, so not many heat will go out. Okay, not many heat can escape, can run away. Yeah, you don't want the heat to run away to surrounding, because if the heat run away to surrounding, later on your experiment result will be wrong. Your experiment result will not be accurate. Yeah, so we don't want the heat to run away to surrounding. So always remember, the biggest challenge when you do the experiment for heat is always the heat loss to surrounding. So we want to minimize, we want to reduce the heat loss to the surrounding. Okay, so that's it. So now, after we cover the polystyrene cup with lid, so the next thing is that we want to stir the mixture with thermometer. Yeah, so this thermometer, we use it to stir the copper sulfate and zinc. After copper sulfate and zinc mix together, you use the thermometer to stir, to kacau lah. Okay, then you need to record the highest temperature, measure the highest temperature. So the temperature will go up lah. Temperature go up, so you need to measure what is the highest temperature that you can get. Okay, so then repeat this entire experiment by changing the X metal powder and with the zinc powder. So initially we have a zinc powder, so you repeat the experiment again. So you repeat the whole thing, but now you change the zinc powder, become another powder called metal X powder. So that's what we want to do. Okay, so we want to study the heat of displacement for two things. Okay, we want to study the heat of displacement for copper sulfate and zinc, and copper sulfate and X metal powder. Yeah, we use two different metal powder, and then we want to compare their heat of displacement. So that is the purpose of this experiment. Okay, so that's it. So now we want to record the reading, okay, for this experiment. So how to record the reading in this experiment? Okay, so when you want to record the reading, so first of all, this one, the result, you have to get it yourself. So you have to go into the lab, you have to do the experiment, then only you can get this result. Then only you can get this result. Yeah. So when you do the experiment in the lab, you will notice that what is the initial temperature. Okay, what is the initial temperature? Okay, what is the original temperature that you are getting? Okay, So the initial temperature, you need to check the thermometer. So let's say the initial temperature, I get 30. So one of the very important skill is this. If you write 30, they can penalize you. Why? When you do paper 3, one of the very important thing is you need to measure the reading. You need to take the measurement. You need to know, okay, how much is the reading? When you want to measure the reading, you must make sure you put the right decimal point. How many decimal points you should put in your answer? That is very, very important. So many students only write 30 or only write 40. They didn't put the right decimal point. That is wrong. So they are very particular on the decimal point when it comes to paper 3. So listen. So what is the right decimal point you should put? So 99% of the time, you will use 1 decimal point. For example, if they ask you to measure the volume, 1 decimal point. If they ask you to measure temperature, 1 decimal point. If they ask you to measure the length, okay, the length, how long is a substance, 1 decimal point, for example. There's only 2 special cases that you need to put 2 decimal point. There are 2 special cases you need to put 2 decimal point. The first one is burette. So burette is a very long tube that we learn in your Form 4 Chapter 6. Form 4 Chapter 6, when you do titration, you will use a burette. So if you have a burette, you must record in 2 decimal point. If you have a burette, everything has to be in 2 decimal point. Number 2, if you have electronic balance. So electronic balance is to measure the mass. So if they ask you to measure the mass of the electronic balance, okay, so you will have to use 2 decimal point as well. For example, if I put the electronic balance, I put something here, I measure. So the reading is 7. Don't put 7, it should be 7.00 gram. So you must put 2 decimal point. Okay? So electronic balance and burette, you have 2 decimal point. Other than that, 99% of the time we put 1 decimal point. So in this case, how many decimal point we should put? So we measure the temperature using thermometer. So thermometer is not the 2 special cases, it's not the burette, it's not the electronic balance. So 1 decimal point will do. So 30.0. Okay? So highest temperature, same thing, you have to do the experiment yourself to figure it out. So let's say I get 33.0, that is the highest temperature. Okay? So same thing, I repeat for experiment number 2. Let's say the initial temperature is 30. Remember to put 0.0. Okay? Always need to put 1 decimal point. So highest temperature, if I measure, I get 35.0. All these numbers, all these values, don't memorize. So you have to do the experiment and you have to get it yourself. So how to get temperature change? Very simple. Take the highest temperature minus the original or initial temperature. 33 minus 30, you get 3. Same thing, if here 1 decimal point, this calculation also 1 decimal point. So 35 minus 30, you get 5. Don't put 5 only, put 5.0. So please watch out the decimal point. So in this question, they will award you with 4 marks. Okay, where the 4 marks coming from? If you get these 2 value correctly, 1 mark. These 2 value correctly, 1 mark. These 2 value correct, 1 mark. So another 1 mark is given when you have 1 decimal point. If all the answer here is correct, but you don't put the 1 decimal point, they will give you 3 marks instead of 4. Okay, so 1 mark is given when all the answers is given in 1 decimal point. Okay, so that's it. So this is how you get the reading. This is how you measure and record the reading for the first one. So next one. So the next question is asking you for the observation. So observation is what? Observation is what you can observe. Okay, what you can observe. So observe is what? What you can see, what you can smell, what you can taste, what you can hear, or what you can touch. Okay, so it's related to this. Anything you can see, you can smell, you can taste, you can hear, you can touch is called observation. Okay, so in this experiment, so normally we focus on what we see lah. Okay, so what you can see. So in this experiment, you can see that when you put zinc in the solution, the temperature increased by 3 degrees Celsius, from 30 become 33. When you put the X metal powder into the solution, the temperature increases from 30 to 35. So you can see the temperature increases. So you can say temperature increases. This is what you can see. Or you can write thermometer reading increases. Thermometer reading increases. You can see that the thermometer, the value is getting bigger and bigger. Okay, so that's what you can see. All right, So if you don't want to go for this answer, you also can go for other one. Okay, let's say if you don't want to see it, okay, you can go to touch. If you go to use your hand and touching the cup, what you will feel, because temperature from 30 go up to 33, what? Temperature from 30 go up to 35. So you can really feel that the cup actually become warmer. The cup become warmer. Okay, the cup become warm. All right, become warm. All right, because temperature increase. When temperature increase, you put your hand on the cup, you will feel the cup become warmer. So you can see, you can write this, the polystyrene cup become warm. Okay, some student will write, sir, can I write hot? Actually can, but not advisable. Why? Because 30 to 35 not really hot lah, okay, only 35 what? 30 increase to 33, so not to the extent of hot. If let's say the temperature go from 30 all the way become 90, then yes, the temperature is high enough, then you feel hot. But now temperature only increase a little bit only. So if the temperature increase a little bit only, the word warm is more suitable compared to the word hot. Okay, so I don't think the word hot is good lah. I like to use the word warm. Okay, so if you don't want to write temperature increases, you also can write my observation. I can feel that the polystyrene cup become warm. Also can, huh? Okay, what else you can see? Okay, if let's say you do this experiment yourself, you should able to see this. Initially, copper 2 sulfate solution, the color is blue. Why? We learned before, Cu2 plus. Copper 2 sulfate inside got Cu2 plus. So if the solution got Cu2 plus, the color is blue. So initially it's blue. So if you do this experiment, you open your eyes and see, you will able to see that the blue color is actually getting lighter and lighter. The blue color actually will become colorless. Okay, or you can say the blue color become paler. All right. So you can write this. The observation, you can go to write the blue color of the copper 2 sulfate solution. The blue color of the solution become paler. So if you don't want to say paler, you can say colorless. Also can, no problem. So based on what you see. Okay, so here I give you 3 observations. This is the first one, this is the second one, and this is the third one. So in exam, do you need to write all of them? No, you don't need to write all the observation. No need. You don't need to write all the observation. Out of the 3 observation here, you just need to give 1. Just give 1 observation is good enough already. Yeah? So that's what you can see. Yeah? Done. Okay, the next one. So the next part is this. When they ask the paper 3, one of the very common question they love to ask is this. Let's read the next question. So the next question they are asking us, what is the inference? So what is inference? Inference means you have to explain the observation. So when you observe something, okay, when you observe something, you need to explain why. Okay, like for example, if let's say you see the temperature increases, you must tell the people why. You see the blue color become paler, you must tell the examiner why. Why the blue color become paler? Okay, and when you feel that the polystyrene cup become warm, when the cup now become warmer, why? Why the cup become warmer? So you must be able to explain. Okay, so how to explain? Very simple. Remember, don't over explain, don't make the answer long. Just remember keys. Keep it short, keep it simple. Keep the answer short and keep the answer simple. That is what you need to know. Okay, keep the answer short and keep the answer simple. Okay, so how are we going to do this? Okay, how are we going to do this? How are we going to tackle the question? Okay, so remember, when temperature increases, why? Why temperature increases? When you do the experiment related with heat, when you do the experiment related to heat, you always need to know there are 2 important things. One is endothermic and one is exothermic. Okay, endothermic and exothermic. So if the reaction is exothermic, the temperature will increase. If we have endothermic reaction, the temperature will decrease. That's it. So remember, when you see temperature increases, you know the reaction is exothermic. When you see the temperature decreases, you know the reaction is endothermic. That's it. So in this case, what we see, okay, in this case, we see the temperature increases. we can see the polystyrene cup become warmer. We can feel the polystyrene cup become warmer. So when polystyrene cup become warmer means what? Temperature increase, isn't it? Same meaning lah. So when temperature increase or when the cup become warmer, why? Why the cup become warmer? Why the temperature increase? Because the reaction is exothermic. Okay, we have exothermic reaction. Because exothermic reaction will increase the temperature. Always remember, exothermic reaction will increase the temperature. Okay, so that's how we explain. So why the temperature increases? Because this chemical reaction is exothermic. That's it. So write these 3 words only, then you can get full marks already. Okay. So why the blue color of the solution become paler? Why? Why the blue color become paler? So this one we learned before. So same thing. You must first understand in the cup what you have: copper sulfate solution. So who give you the blue color? The blue color coming from Cu2 plus. So if you have many Cu2 plus, the blue color is very dark. But if the Cu2 plus become lesser and lesser, if we have lesser and lesser Cu2 plus, now the blue color will become paler, become lighter. Very simple. Okay, the more Cu2 plus you have, the darker the blue color. So if today, why the blue color go from a dark blue to become a light blue? Because the Cu2 plus become lesser and lesser. Because if you have many Cu2 plus, the blue color is dark. If you have very little Cu2 plus, the blue color is pale. Okay, so that's it. So why the blue color become paler? Why the blue color become lesser and lesser? Because we have less Cu2 plus already. But if your answer you write less Cu2 plus, you get 0, no marks. So you cannot write the word less. So you must use a proper word like this. So when you have a solution, we always use the word concentration. Okay, when you have a solution, we always need to say concentration. So we have concentration of Cu2 plus ion decreases, which means what? In the cup, the Cu2 plus become lesser and lesser. So to tell people about how many Cu2 plus inside the cup, we use the word concentration. Concentration of Cu2 plus ion decreases. So there are lesser and lesser Cu2 plus in the cup. That's why the blue color become lesser. That's why you can see the blue color turn paler. The blue color turn paler. That's it. So you see, this is what I observe. I can see that the blue color become paler, and I explain it why. That is inference. Inference, I need to explain why the blue color become paler. Concentration of Cu2 plus ion decreases. Because remember, the blue color is coming from Cu2 plus. So when the Cu2 plus become lesser, the blue color will become paler. That's it. Yeah, that's quite easy lah. That's quite simple. Okay, next one. Okay, when you do all these experiment for your paper 3, so they will, okay, if they ask us the paper 3, one of the very common way they ask is that they will always ask something about variable. Yeah, they will always ask something related to the variable. Yeah, variable here. Okay, so we have 3 variable you need to know. One is manipulated variable, one is responding variable, and one is fixed variable. So what is manipulated variable? Something that you change in the experiment, something that you purposely change in the experiment. So how to find manipulated variable? There are 2 easy way. For you to find your manipulated variable. The first one is you look at the table. You look at the table here. Okay? You can see the table, what they change. They change the metal powder, right? Set 1, the metal powder, they use zinc. Set 2, the metal powder, they use X. So they purposely change the metal powder. So if you want, you can write here, type of metal, because they change the metal zinc and they change the metal X. So sir, can we write the type of metal powder? Yes. Okay, you can write type of metal powder. So the word powder is optional. Even you don't write the word powder, it's okay. Yeah, even you don't write the word powder, you only write type of metal is okay. Okay, if you don't want to write type of metal, you also can write it out like this. Okay, so what is the metal they use? What they change? Initially they use zinc, then they use X. So the manipulated variable, you also can write what? Zinc powder and metal X powder. Okay, because this is what they do, right? Initially they use zinc powder, then they change it and become metal X powder. So this is what they change in the experiment. So this is the manipulated variable. So you can write this or you can write this. So same thing, the word powder is optional. So if you only write zinc and metal X, also full mark. If you only write the word zinc and metal X, you don't write the word powder, is also full marks, because again, the word powder is optional. You write the word powder or you don't write it, it's okay. Yeah, it's okay whether you write the word powder or you don't write the word powder. It's completely fine. So the next one is responding variable. So what is responding variable? Responding variable is, so remember, manipulated variable is what you change. Anything you change just now. So what is responding variable? The result. Okay, or we call the observation. Anything you observe, or what is the result that you are getting? What is the result you are getting? Okay, what is the result you are getting? So how to get the responding variable? So same thing, you have two methods. There are two methods that you can find the responding variable. The first method is look at the table. Look at the table. So when you use the zinc, what is the highest temperature you are getting? Because remember, what is the temperature? Okay, you can say this. When you use the zinc, what is the result you get? You get 33 degrees Celsius. Or you can say temperature change. Okay, the temperature change is 3. When you use the metal X, what is the temperature change? 5. Or you can say the highest temperature is 35. So you can see what is the changes. The initial temperature is the same. When you use different manipulated variable, when you use different metal, you get different highest temperature, or you can say you get different temperature change. So that's it. So this highest temperature or the temperature change can be our responding variable, the result. When you use different metal, you will get different highest temperature, or you will get different temperature change. Okay, you will get different temperature change. So that's it, very simple. The result of this experiment is responding variable. Okay, so when you use the zinc powder, what is the highest temperature I get? When you use the zinc powder, what is the temperature change I get? Okay, same thing. When you use metal X, what is the highest temperature? What is the temperature change we are getting? So you can see this one got changes, right? Okay, when you use the zinc and X, the highest temperature is different. When you use the zinc or metal X, the temperature change is different. So these are the result that we wanted. So those are responding variables. So responding variable is the result that we want. So if you don't want to write the highest temperature or temperature change, you also can write this. Another way that you can find your responding variable is this. Another way you can find the responding variable is go to read the first line of the question. Read the first line of the question. Go to understand the purpose or the objective of the experiment. So you must understand what the experiment want to do. What is the main purpose of the experiment? Because when you know what is the purpose of the experiment, you will know that is the result that you wanted. Okay, what do I mean? What do I mean? So you see here, what do I mean? So you go to read the first line of the experiment. Okay, you have to carry out an experiment to compare the heat of displacement of copper from copper sulfate solution with the zinc and also the X powder. So this experiment, what is the purpose? They want us to compare the heat of displacement when they use two different metal powder. When they use the zinc metal powder and the X metal powder, what is the heat of displacement they want? So the main purpose of this experiment is what? Okay, you see, this is the diagram to determine heat of displacement. So heat of displacement is the purpose of this experiment. So the main result, the main purpose of this experiment is we want to get the heat of displacement. So this heat of displacement is our responding variable. When you use the zinc, what is the result? What is the heat of displacement that you are getting? When you use metal X, what is the heat of displacement that you are getting? So if you don't want to write temperature change or highest temperature, you also can write heat of displacement. Also can. Yeah, you also can write heat of displacement, okay? Because that is the result that we want. So remember, responding variable is the result that you are getting when you change the manipulated variable. So when you use the zinc powder, what is the result you are getting? You will get different highest temperature, you will get different temperature change, or you will get different heat of displacement. Same goes to metal X. When you use metal X, you will get different highest temperature compared to the zinc. When you use metal X, you will get different temperature change compared to the zinc. When you use metal X, you will get different heat of displacement. So these three answers, you choose one of them. You don't need to write all. You don't need to write all of them. Just choose one of them as the answer will do. Okay, one of them as the answer will do. Yeah, that's it. All right. So that is what you want to do. Okay, this is the steps that you need to follow, and we are done. Okay, next one. Okay, fixed variable. Fixed variable, sometime in some of the question they call it as constant variable. Fixed variable also can call as constant variable. So what is constant variable? Something that you need to fix it in this experiment because they can kacau, they can affect the result. So something that can affect our result and you need to fix it. Okay, something that can kacau or affect the result that we wanted and you need to fix it. So in this case, what we need to fix it? So if you look at the displacement, what is the important thing? This metal, powder, and the solution. So do we fix the powder? No, we change the powder. We change the powder from zinc to metal X. So we change the metal powder. So that is not constant variable or fixed variable. So do we need to fix the copper 2 sulfate solution? Yes, because if you change the copper 2 sulfate solution to something else, let's say you use zinc sulfate solution, you use aluminium sulfate solution, the result will be very different. So you need to fix the solution. You cannot change the solution. You cannot say, oh, the first experiment I put zinc in the copper sulfate solution, the second experiment I put X in aluminium sulfate solution. Cannot. The solution for both experiments need to be the same. Okay, you only can change the powder, but this solution cannot change. So when you want to fix a solution, you always fix two things. Remember, when you want to fix a solution, you always fix two things. Number one, you need to fix the volume of the solution. When you have a solution, you need to fix it. For example, the first experiment you use 50 cm cube of copper sulfate. Second experiment, you must also use 50 cm cube. You cannot change the volume. You cannot say the first experiment I use 50, the second experiment I use 150. Cannot, because when you use different volume of the solution, it will affect the final result. No. So that's why the volume cannot change. Second one, when you have a solution, you not only need to fix the volume, you also need to fix the concentration. When you have a solution, you also need to fix the concentration. You also need to fix the concentration of the solution. Okay, you need to fix the concentration of the solution. Okay, so you must fix both. You cannot say I only want to fix the volume of the solution, I only want to fix the concentration. Cannot. If you have a solution, you need to fix both. You need to fix both of them. So in this case, the fixed variable, you can go to write concentration and volume for copper 2 sulfate solution. So you need to fix the concentration, you need to fix the volume of copper 2 sulfate solution. So can we write volume then only concentration? Yes. The sequence doesn't matter. You can write concentration first or you can write volume first. It's okay. It doesn't matter. It doesn't matter. You can write volume, you can write concentration first. It's okay. Yeah. So apart from the concentration and volume, you also need to fix what? This metal powder. This metal powder, you need to fix the mass. You cannot say, when I use the zinc powder, I use 1 gram. When I use the metal X powder, I use 7 gram. Cannot. When you use different mass of the powder, the final result will be different. Cannot. So it must be fair. How to make sure it's fair? If you use 1 gram of zinc powder, so the metal X powder, you must use 1 gram as well. So you cannot go to change the mass of the powder. Okay? Because the mass of the powder can kacau the result. So anything can kacau the result, you need to fix it. They are fixed variable, or we call constant variable. So that's it. So we need to fix the mass of metal. That's it. So do we need to write mass of metal powder again? The word powder is optional. You write the word powder is okay. You don't write the word powder. You just write mass of metal is completely fine. That's it. So this one, you have 2 answers. You don't need to write both. Just write only one of them. Okay, you can only write the first answer or you can write the second answer. Up to you. That's it. So that is the variable. So each variable will give you 1 mark. So 1 mark, 1 mark, 1 mark. So that's why the total marks awarded here, it's 3 marks. They will give you 3 marks for this part. Okay, that's it. Okay, so we are done with this. So the next question is this. The next question is asking us, what is the hypothesis? Okay, what is the hypothesis of this experiment? So first of all, you guys must understand what is hypothesis. So a lot of people, when it comes to hypothesis, they always memorize the answer. They always memorize the answer. They say, oh, hypothesis is what? The more, blah, 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 the more or the less, blah, blah, blah. No. Hypothesis not necessary must follow this format. Hypothesis not necessary, not a must to follow this format. So what is hypothesis? Hypothesis is a relationship. Okay, hypothesis tell us the relationship between manipulated variable as well as responding variable. So when you can relate the manipulated and responding variable together, so you will be able to get a good mark. You're able to get a good score. You're going to get a good score for the hypothesis. Okay, so in this case, what is the manipulated variable? Type of metal, or you can say zinc and metal X. And then what is the responding variable? Highest temperature, temperature change, or heat of displacement. So one of the mistake the students will use is this. One of the mistake the student will write is this. They will write different type of metals will produce different highest temperature, or different temperature change, or different heat of displacement. So this is what a lot of students will write. Okay, a lot of students will just write, okay, different types of metal will give us different highest temperature, or they will write different type of metal will give us different temperature change, or they might write different type of metal will get different heat of displacement. Is this answer wrong? No, this answer is okay, but this answer is not the best. This answer is not clear enough, because you didn't give me a very clear relationship. The relationship is not clear enough, because when you say different type of metal, I don't know what metal you are using. Okay, you only say different type of metal. What metal is it? And then when you say different highest temperature, I don't know who have different highest temperature, who have different temperature change. Temperature is what? Change a lot or change a little. I didn't. No. If you say heat of displacement, I also don't know who have higher or who have lower heat of displacement. So the relationship is not clear enough. So what is a better answer? So the better answer you can write is this. So initially when you use the zinc, so this zinc you put in what? The zinc you put in this copper sulfate solution, right? Okay, so you see when you put the zinc and also the copper sulfate solution, so the highest temperature is what? The highest temperature is how many? The highest temperature is 33, the highest temperature is 35. So you can see that this one, the highest temperature is more. The highest temperature is more. So zinc and copper sulfate, the highest temperature is lesser than the X, the metal X and copper sulfate, isn't it? When you use the zinc powder put in copper sulfate, the highest temperature is 33. When you put the metal X and copper sulfate, the highest temperature is 35. Okay, so that's it. Okay, so you can write something like this. Okay, you can write you can write something like this. Okay, when the X and copper sulfate solution react, when you mix the X and copper sulfate together, it will produce higher temperature than the zinc and copper sulfate. True or not? You see, when you mix the zinc and copper sulfate, the higher temperature, okay, so the temperature you get the temperature you get X, when you add X and copper sulfate, the temperature you get is higher than the zinc and copper. This one 35, this one only 33. So you see the answer is this. Okay, when X and copper sulfate mix together, the temperature is higher than the zinc and copper sulfate. So a very clear relationship. You see, what is my manipulated variable? The zinc and metal X. You see, so I got mentioned when I use the zinc, when I use the metal X, and I also relate with my responding variable. So what is my responding variable? Highest temperature, or you can say temperature change. Okay, so you see the temperature is what? X and copper sulfate, the temperature change is higher. Okay, so something like that. So this is a very clear relationship. Okay, this is a very clear relationship. Okay, so that's it. So some students, they are very careless. They only write when X and copper sulfate solution reacts, they produce higher temperature. That's it. So, but they didn't say this X and copper sulfate higher temperature than who? X and copper sulfate, the temperature higher than who? Higher than zinc and copper sulfate. So this is how you write a good answer. So if you don't want to write this answer, you also can write this. Okay. So what is the manipulated variable? Zinc and metal X. So when zinc you put in copper sulfate and the metal X put in copper sulfate, what is the responding variable? Heat of displacement. So who have higher heat of displacement? Heat of displacement, you can look at the temperature change. The greater the temperature change, the higher the heat of displacement. So this one, experiment number 1, when you use the zinc, temperature only change for 3 degrees Celsius. When you use experiment number 2, temperature change for 5 degrees Celsius. The higher the temperature change, the higher the temperature change, the greater the heat of displacement. So this one, the heat of displacement is greater. So this one is the heat of displacement between who? Between the X and who? X and copper sulfate. So now you put the metal X in the copper sulfate. So you also can write, okay, the heat of displacement for X and copper 2 sulfate solution is higher than the heat of displacement between zinc and copper 2 sulfate. Also can, yeah. So at least you relate the manipulated variable and also the responding variable, which is the heat of displacement. Okay, so you also can write this, heat of displacement, okay, between metal X and copper sulfate solution is higher than heat of displacement between zinc and copper sulfate solution. Okay, so you see a very clear relationship. So what is my manipulated variable? Metal X and also the zinc. So what is the responding variable? Heat of displacement. So what is the relationship? Higher. So you see, that is how you get hypothesis. You must relate manipulated variable, responding variable, and you must give them a very clear relationship. You must mention a very good, very clear relationship. That's it. Okay, so that is for hypothesis. Okay, so next one, based on the result, you need to compare the differences in the temperature. You must compare the temperature change and you need to explain. So you have set 1 and set 2, you need to compare the temperature change. So quite easy lah. Set 1, temperature change for 3 degrees Celsius. Set 2, temperature changes for 5 degrees Celsius. So who have higher temperature change? Set 2. Okay, so you just need to mention, okay, temperature change for set 2 is higher than set 1. Okay, so when you compare, you must say set 2 higher than set 1. You cannot only say temperature change for set 2 is higher. Higher than who? Higher than set 3, higher than set 4, higher than set 7. You need to highlight set 2 higher than who? Higher than set 1. Okay, you need to specify. Alright, so if you're able to write this comparison, you already completed the first objective, because the first objective is what? Compare. So you're able to get 1 mark from here. So then the next one, you must be able to explain. So explanation is another 1 mark, and this is where a lot of students always having some issue. This is where a lot of students might having some issue. So how to explain? So this experiment is about heat of displacement. Okay, this is experiment is about heat of displacement. So when you want to explain about displacement, okay, so you must know your gangster bully concept. So to explain gangster bully concept, you can use ECS or you can use the electrode potential value. You can use ECS or you can use electrode potential value, which is E0. Okay, if you want to use ECS, what is the logic? Okay, what is the logic? Okay, why the temperature for these two, for X is higher than zinc? X, the temperature change is 5. Zinc, the temperature is 3. Why and how? Okay, so very simple. So if you look at the ECS that we have, so this is the ECS that you learn in your Form 5 Chapter 1. So we know the zinc is higher than copper, yeah? And the temperature change is 3 degrees Celsius. But they didn't give us the metal X, right? They didn't give us the metal X in the ECS. So how are we going to know? How to know where is metal X in the ECS? So very, very simple. Okay, how to know where is the metal X in the ECS? Okay, so the idea is this: the higher the metal in the ECS, so they will produce higher temperature. The higher the metal in ECS, they will produce higher temperature. So if zinc and copper produce 3 degrees Celsius, where is metal X? Metal X should be higher than zinc, isn't it? Because only when the metal X higher than zinc, you see the gap here is even bigger. The bigger the gap, the more temperature they produce. So only you get 5 degrees Celsius, isn't it? The X cannot be here, because if X is here, the gap is smaller. When the gap is smaller, the temperature is lesser. It should be less than 3 degrees Celsius, okay? Because the gap is even smaller than this one. So the bigger the gap, you get greater heat of displacement. The smaller the gap, you get lesser heat of displacement. So although we didn't know where is the metal X, but we look at temperature, we know already, zinc and copper sulfate temperature increased by 3 degrees Celsius. The X and copper sulfate temperature increased by 5 degrees Celsius. So since the temperature increased more, you can expect the metal X should be even higher than the zinc. Okay, metal X should be even higher than zinc. So now how to explain? How to explain? So why the temperature is greater? Because zinc is higher than zinc. Okay, sorry, X is higher than zinc, but you cannot write the word X is higher than zinc. Cannot. You cannot say X is higher than zinc. So in ECS, the higher the metal, you use the word more electropositive. Okay, the higher the metal in ECS, we use the word more electropositive. So zinc, so X is more electropositive than the zinc. So this is the answer you can write. So you can write this, okay? So why? Explain your answer. X is more electropositive than zinc. Because when X is more electropositive than zinc, it means that X is higher than zinc in ECS. So when X is higher, the gap is bigger. The bigger the gap, the more temperature they can produce. That's why it's 5. Okay? So remember I said you have 2 methods to explain about displacement. So displacement, if you don't want to use the ECS, you also can use E0 value. You also can use E0 value to explain. How to use the E0 value? So look at the E0 value given here. Look at the E0 value here. Okay, E0 value, how you use? Quite simple. So remember, the more negative the E0 value, it means that it's more powerful gangster. So zinc is negative 0.76. So it's more powerful than copper, which is positive 0.34. That's why zinc can produce 3 degrees Celsius. But look at the X. X is negative 2.38, which is more negative than the zinc. X is more negative than the zinc. So X is even more powerful. So when X is even more powerful gangster, so the X will produce much more temperature, 5 degrees Celsius, compared to the zinc. Okay? So how are you going to explain it? How to tell people X is even more powerful gangster than zinc? So when you want to use standard electrode potential value, you need to see who is more negative. So you can see the value for X is more negative than the value for zinc. Okay? So that's it. So you can look at here. The answer, you can also write in this way. You can write the E0 value, okay, of X. If you don't want to write E0, you can write the full name, standard electrode potential. You can write the full name, standard electrode potential, okay? So the standard electrode potential value for X, it's more negative than the E0 value for zinc, okay? Because the more negative the E0 value, it means more powerful gangster. So X is more powerful than zinc. When X is more powerful gangster, you will produce higher temperature. So remember, in metal displacement, the more powerful the gangster, the greater the temperature change. The greater temperature change they will produce. So that's it. So these two answers, you can write either one. You can write this one or this one. So I write or here. You don't need to answer both. You don't need to answer both. You just need to answer either one. Yeah, just answer either one of them. Okay, that's it. All right. So that is what you need to know. Okay. So now let's go on to question F. Okay. So question F. So state the operational definition for heat of displacement. So a lot of students always get 0 marks for operational definition. So operational definition, the full mark is 2 marks. So how to get a good score, how to get a good mark for operational definition. So first of all, you all must understand operational definition is not the same as the definition that you memorize in textbook. Not the same. Yeah, operational definition has nothing to do with the definition that you memorizes from textbook. Nothing. So operational definition, you must always write 2 things only. When you want to write operational definition, you must write 2 things. What you need to do. What you need to do in this experiment, and what you will get. Okay? Or what you will observe. Okay? What you can see, what you can observe in this experiment. That's it. Every time when you want to write operational definition, you just need to mention what you need to do and what you will observe. Okay, now let's look at it. Let's imagine. So in this case, in this question, they are asking us for the operational definition. They're asking us the operational definition for heat of displacement. So you ask yourself, what you need to do to get the heat of displacement. Okay, so imagine. So in this experiment, what we need to do to get heat of displacement? So look back to the picture. So in this experiment, to get the heat of displacement, we can mix the zinc powder with copper 2 sulfate solution, or we can use metal X powder to mix with the copper 2 sulfate solution. True or not? So okay, you can either mix the zinc powder with copper 2 sulfate solution, or you can mix the metal X powder with copper 2 sulfate. So this is what we do. Okay, so this is what we do. So you can mix zinc with copper sulfate solution, or if you don't want to mix the zinc with copper sulfate solution, you also can mix the X. You also can mix the X with copper sulfate solution. That's what we do. So what we observe, what we want to see. So in this experiment, what we can see, you can see that temperature from 30 become 33, 30 to 35. So what you can see, 30 to 35, 30 to 33. You can see this thermometer. This is the thermometer, right? You can see the thermometer, the reading is increasing. You can see that the thermometer reading increasing. That's what you can see, right? You can see from 30 become 33. You can see from 30 become 35. So you can see thermometer reading increases. So that's it. Okay, that is what you observe. Okay, so I can observe thermometer reading increases. So then you just combine together. So what is operational definition? So what I do when zinc is mixed with copper 2 sulfate solution. So this is what I do. So Mr. Martin, if I don't want to write zinc, can I write X? When X mixed with copper 2 sulfate solution, yes, no problem. When zinc or when metal X is mixed with copper 2 sulfate solution, what I observe, I can see thermometer reading increases. Thermometer reading increases. That's it. So if you write this, you get 2 marks. So focus on what you do and what you observe. That is how you get a good mark for operational definition. So some student may ask, sir, if I don't want to write thermometer reading increases, can I write temperature increases? Because I can see 30 become 33, 30 become 35. I see temperature increases. Can I write that? Yes. But thermometer reading is even better. Why? I can directly tell the examiner, I observe the reading of thermometer. I know the temperature come from where? Thermometer. So when I mix zinc and copper sulfate, I can see the thermometer increase. So temperature increase is okay lah. You can write temperature increases, can, but thermometer reading increases is even better. Okay, because you can tell the examiner directly the temperature come from thermometer. So the answer is even better. So the better the answer, so you will have a higher chance to get full marks. Okay, so remember, from now and onward, Operation definition, you don't need to memorize. You don't need to memorize operation definition. You can do it yourself, okay? Just write the answer of what you need to do in the experiment and what you expect to observe, what you can see as the result of the experiment. So that's it, okay? So that is what you need to do, okay? All right. So remember this, okay? So nothing, all right? I think this is the idea, okay? So the last one, how to write ionic equation for set 1. So this is a very important skills that you also learn in your Form 5 Chapter 1. So how to write the ionic equation? So to write ionic equation, always start with chemical equation. So start with chemical equation first. So set 1, we mix the zinc powder and copper sulfate. So this is a gangster bully concept, metal displacement. Zinc is a more powerful gangster than copper. So zinc robbed the girlfriend, sulfate, to become zinc sulfate. So after the sulfate robbed by the zinc, so now the copper stand alone. The copper has no girlfriend already. So this is the chemical equation. So how to change the chemical equation to ionic equation? So ionic equation come from the word ion. Ion means what? Charge. Okay, ion means charge. So you need to list out the charge. You need to list out the charge for everything. So what is the charge for zinc? Many people write Zn2 plus, which is wrong. Why? Okay, why is not Zn2 plus? When the metal come alone, when the metal come alone, it has no charge. When metal come alone, when metal not combined with anything, it has no charge. So the zinc got no charge. So copper is a metal. Does the copper has charge? Yes, because copper combined with something else. So always remember, if the metal come alone, if the metal do not combine with anything, no charge. If the metal combine with something else, got charge. So this copper is a metal, it combined with something else, it got charge. So copper is Cu2 plus. Sulfate, SO4 2 minus. So go on, the arrow. So the zinc is a metal, it combined with something else. When metal combined with something else, got charge, the N2 plus. Sulfate, SO4 2 minus. So the copper here is not Cu2 plus. Why? Because this copper is a metal that come alone. When the metal come alone, when the metal not combined with anything, it has no charge. So then you compare the left and right. Anything same, you cut. So the SO4 2 minus, SO4 2 minus, you cut. That's it. So after you cut, the remaining answer, Zn plus Cu2 plus become Zn2 plus and Cu. This is the final answer for your ionic equation. So if you're able to write the ionic equation, you are able to get 1 mark. Okay? So this is one of the most important skill for your what we call that, for your chemistry, for the chapter redox. How to write a good ionic equation is so important. You must able to know how to write the ionic equation. Yeah? So that's it. So you see, actually not very hard, isn't it? The answer that I give, the answer that I wrote here is not something very, very fancy, right? Not something very hard. It's quite straightforward, okay? Like temperature increase, inference. Why? Why temperature increase? Exothermic. Why the blue color become paler? Blue color come from Cu2 plus. So when blue color become lighter, because Cu2 plus become lesser. Okay? So something like that, okay? So remember, at the end of the day, when you do your paper 3, don't make it too complicated. Remember, don't make it too complicated. So remember the rules I say what? Kids, keep it short and simple. Keep it short and simple. So there's a general rules that we can use for your paper 3. Okay? And lastly, please spare some time to do your paper 3. A lot of students always say, sir, I'm not doing well for paper 3. I didn't score well for paper 3. But you ask yourself, do you spend some time to practice on paper 3? Do you really do the exercises for paper 3? Do you ever do that? Okay? So if you never spare any time for paper 3, so how can you improve on that? Because I know a lot of students who spend a lot of time to do paper 1, who spend a lot of time to do paper 2, but they never spend any time to do paper 3. Okay? So that's something very wrong. So you must at least try a few sets of paper 3 before your exam. Okay? So with that being said, yeah, we are all done with today's lesson. So hopefully, by discussing the paper 3 of MRSM 2022, you guys can get some rough idea on how to answer paper 3, like how to give a good inference, how to write hypothesis, how to give operational definition. Okay, all these are very, very important. Okay, so I hope you learned something from today's lesson. Yeah, and I will see you in the next video. Yeah, good luck everyone.